Hello and welcome to Beginners Python and Machine Learning. My name's Tim Cummings. Every Wednesday we do a session here on it could be Python or it can be some machine learning using Python, and we're really designed for beginners so they can ask questions. So this is a live session. I'll be listening here on the YouTube chat and also on the Slack channel, so you can see our Slack channel here, Learning to Code in Beginners Python. So you can there's instructions below the video and on the meetup site telling you how to join that Slack channel if you're not a member already. You can ask questions here during the session or even during the week between the sessions, and someone can get back to you. All right. I want to show you that I'm listening to the YouTube chat as well, and I'm not, so I better open that up. So I'll just pop out the chat. Might get a bit of echo for a bit. There's the YouTube chat. All right, I can close that. All right, yeah, so ask questions during the session on there. Even if I've got ahead of you, feel free to ask any question, even if it's just something like slow down or can you say that again. All right, so what we're going to do, because of absolute beginners, we can use, we're going to use Google Colab, which means you don't even need to install Python onto your computer. Google Colab's a fantastic tool for learning what Python does, and I still use it myself. If I'm not sure what the effect of something's going to be, I'll just jump into Colab, write a few lines of code and see what's going to happen, and get a quick answer. So, and I provided a notebook for you already, and the link is here. It should be in the YouTube as well. Hello, Agupta. So let's click on the link and open up a Google Colab, the workbook. Now when it opens up, it's going to be the one that I've shared to you from my other account, but you won't be able to make any changes to this. So the first thing you want to do is copy it to your drive so that you can make changes. So there's a big button here, copy to drive. If that's not there, you can also go to the file menu and say save a copy in drive. So let's click on copy to drive. And what Google Colab does, they actually run a virtual Linux machine with Python running on it for you and Jupyter Notebook to access that Python. So it's very, very kind of them to do this for us, and a very useful tool. Okay, so you can see we're in the copy now. It says copy of Meetup 180, and that'll be saved to your Google Drive. Now I'm going to share this as well, because anything I type in this, you can actually load it up, and you get all my typing if you miss something that I've typed on the screen during this video chat. So I'll copy that link and paste it into YouTube chat, and I'll paste it into Slack. All right, so let's have a look at this notebook and see what it is. It's these notebooks. First of all, we should just click on connect, and I'll just save us a little bit of time later on. If you don't do that, it'll do it automatically when we start doing stuff. Okay, so it's a bunch of cells, this notebook. You can see the first cell goes down to here, and this is just a text cell. I've just written some stuff. I've given you a few links to our YouTube, the Colab, the Meetup, and we also store all these sessions in GitHub, or the ones I do anyway, are stored in GitHub. I store them as a Python script, not as a Jupyter Notebook, so that if you don't want to use notebooks, you can run it straight as Python. Okay, so our first challenge is getting Google running, colab running, so see if you can do that. Let me know if you have any problems. This is what we're trying to do. This is like absolute beginners. The first week of every month is for absolute beginners, so you've never seen Python before. I just want to make sure that you can get started, so that then hopefully you can then hang on and we'll go on the wild ride of learning Python. Okay, if you don't use Colab, then you have to install Python, and you can get it from python.org, but we're going to use Colab today. You can also use an IDE, which I would recommend for other things, but you don't need to do that today. I've also written a children's Python coding course, so go to my website pythonator.com to give that one a go. I've just done some updates, so it works with the latest version of JetBrains Academy, which is a teaching tool within PyCharm. Okay, so we've just seen some text cells here, and now we're going to have some code cells. Good, I've got some more people. G'day, Aaron. In the code cell, this is where you put Python code. Up here you're putting Markdown code, and down in these cells you're putting Python code. And at any time you can create a new code cell or a text cell just by hovering between the cells, and it'll come up with one of these buttons. And you'll also find in your menus up here you'll have insert code cell, insert text cell if you want to do it through the menus. Now, so this is our first line of Python. It's a line that starts with a hash, and that just means it's a comment. So comments, any Python line that starts with a hash or any hash in a Python line from then on is just a comment. So it does nothing, but it's just something there to read for you to read later, or for someone else to read. So here we're saying, let's access the IPython help, and you can do that by executing a question mark. All right, so we've typed a question mark here without the hash in front, and now if we run this cell by clicking on the run button there, see it brings up IPython help over here on the right, and that tells you some things about how to use IPython. And IPython is the interactive version of Python we're using here, so it's pretty similar to Python. Stuff you learn in IPython will help you for Python as well, except the question mark, of course, is one thing you can't type in a Python console. That only works in IPython. Okay, so the first thing we're going to look at is variables. Now, variables are basically memory locations where we store data in a computer, and we can give them a name, any name that we like, as long as it's not a Python keyword. So if I wanted to store the number 3 in a place in the computer, I can store it in a variable called A, and by calling it A, I can then get access to it at a later stage to get it back out just by using that variable name. So if I run this cell, it's now been run, and you can see it had the number 2 in it. That means it's been run. This is the number 1, so I can see the order that I've run these cells to, and this one hasn't been run yet. It's still blank. Okay, so we've run this cell 2. We've saved the data value of 3 into the memory location we've called A. Now, to see what's in the value in that memory location, we can use the Python print command. We can say print A, and we just put the A in the parentheses there. Now, sometimes you'll see print commands without parentheses. That's if you're looking at Python 2, so that's a dead giveaway. You're looking at an old version of Python if there's no parentheses here. But this one's got parentheses. We're using Python 3, and there we are. We've looked at the value. It said, what's the value of A? And it's printed out the number 3, and that's because that was what we stored in there. You see how we're jumping from cell to cell, but it still remembers everything that happened in the earlier cells. And that's why it's important for us to know which order these were run in. And that was number 3. But we can go back and rerun any of them if you want, but I won't do that at the moment. Now, in IPython, you can just type the variable name to see what's in it, and that'll be very similar to doing the print command. It just shows us the number 3. In IPython, we can also type in an expression, and here's our expression, a plus 4, and we can see it's 7. Alright, now I've just got a question here. How do I know what version of Python is running? Okay, so it's not a standard, I mean it is a standard feature of Python, but it's not one of the built-in functions to tell us what the version is. So we have to import the standard library called sys, and then we can look at sys.version, and that will tell us what version we're running, and we're running version 3.9.16. So that's not too bad. Colab had a habit of being on quite old versions, but they jumped quickly from 3.8 to 3.9, so we're now on 3.9, so it's quite good. And the latest version is about 3.11. Alright, challenge 2. Add 123 to 456 and display the result. So I've left a blank cell here for you to have a go at that. So type in your Python command that you think is going to display the result of 123 plus 456. And I'm about to do it right now. You can pause the video and do it yourself, or if you think you can do it faster than me, then just start typing. But here we go. I'm going to type it in. 123 plus 456, and I'm in IPython, so I can just click on the play button and it's going to give me 579. Now I've provided the solution here in a slightly different way. This is a way that will work in Python or IPython, and that's to use the print command. So I put the expression that I want to evaluate inside the parentheses of my print function, and then I run it, call it, and it displays the result. So it also displayed this bit of text here. Solution 2 works in IPython or Python, and there's the result. Okay, now I said before that you can't call your variable names any of the built-in keywords. So how do you find out what the keywords are? Well, they've got a standard library that you can import to see what those keywords are, and now I show you as well what version of Python is running, because the keywords can change from Python version to Python version. And the main reason for doing this import is so that when you're not using these functions, you don't lose what's called your namespace. You can use lots of names of things without clobbering stuff that other people have got. Alright, so the Python keywords are things like false, none, true, peg parser, which actually is no longer a keyword in Python 3.10, and as, assert, async, await, break, class, continue. So these are all the names that you can't use for your variables, otherwise it will just give you straight out a Python error. So there's Python syntax error. There are 36 keywords. Now you'll notice function names like print are not in that list of keywords. So you could actually call a variable print, P-R-I-N-T, but that's not going to be very smart, because then you'll no longer be able to use the print function, because every time you use the word print, it would think you're talking about the variable and not the function. Alright, let's have a look at some of these keywords. None, this first one here, that's a value to give to a variable if you don't want it to have a value. So if I say n equals none, and then say show me what's in n, and I run that, and it's just nothing there. So that's basically saying I don't know what the value is. I'm going to set it later, so I'll just put none in there for now. Similarly, there's a keyword in the list called pass. Pass is a keyword which does nothing. You probably won't have a need to use pass at this stage of your career, but there are a couple of times when you need a line of code that doesn't do anything, but is actually not a comment. So sometimes you need that. All right, so we've got a question: is none null, and that is correct. In other languages they call it null or nil, and in Python it's called none. Alright, so you can use long variable names to make your code easier to understand and avoid clashing with keywords. And for Python, the convention is to use all lowercase for your variable name and separate each word by underscores. So this is an example: a long variable name equals 345, and then to display the value of a long variable name, we just put the name of the variable there, and up comes 345. Alright, so Python's a dynamically typed language, which means that it can it works out the type as you're going along. You can save one type of data in a variable, and then later on you can store another piece of data in there which is of a different type. So at any time we can use the type function to see what the type of the value currently stored in that variable is. And for A, which is storing the value 3, it says the type is an integer, int. We can also just put in a bit of data directly. It doesn't have to be a variable name, and say what's the type of this bit of data, 456, and that is also an integer. In later versions of Python they allow type hinting, so you can say I want this variable to be an integer, or I want it to be a float. And that's really useful when you're writing long programs. It can spot errors for you, but it won't enforce it. So even though you say I want it to be an integer, you could then throw a string in there, and it won't stop the program, but your development environment like PyCharm, that should flag to you a warning that you're trying to store a value of the wrong type in that variable. Okay, so integers are whole numbers, so nothing with a fraction, and floats are floating point numbers, so they can have a fractional part represented by a decimal point. So we'll look at the type of B, and B is not defined. Why is B not defined? Because I didn't run this cell up here. You see how this cell has a blank in the square brackets. I forgot to run it. So let's run this cell, and B's got the value 4.5. Okay, Gupta says I missed out on pass. Yes, pass does nothing. So if you want to put in a line of code that does nothing, you just put the word pass. And the reason you'd need that is if you had if A equals B is an if command, and you wanted it to do something, but you're still writing the code, you're not sure what you want it to do, but you need to indent the next line after you've got a colon here. So you indent the line and you put a pass there for now, and maybe a comment to say, to do, fill out what you want to do if A equals B, and come back to it later. But just leaving the comment there is not good enough. It has to be a proper line of code that is indented. So pass is your line of code that does absolutely nothing. All right, let's see what the type of B is now that we've assigned it, and there it is. It's a float, which means a floating point number, or a number with a fractional part represented by a decimal point. Okay, so floating point numbers are stored with a mantissa and an exponent, making it possible to store very large or very small numbers in a small amount of memory. So here's a very large number, 1, 2, 3, 4, 5, 6, 7. So if I have a look how that displays, it converts it to a floating point number. So it gives you a mantissa there and an exponent. So that's saying it's this number times 10 to the power 19. So it's basically you move that decimal point there 19 places to the right to get the proper number. So that's a very large number, and this one here is an example of a very small number. Okay, so I'm getting lots of questions, which is fantastic. Is float and decimal numbers different? Yeah, so float is like the native way of using decimal numbers in the computer, but it does them using binary. It codes them as binary, so you can get what's typically known in programming as a floating point error, when it doesn't exactly convert between the decimal number and the binary number. If you want to get that, if you want to get floating point numbers exactly matching, then you use a class, built-in class called decimal with a capital D, and we'll look at that later. Float is a whole number. That's incorrect. Integers are the whole numbers, and floats are numbers that have got a decimal point. Yep. So you can have, like if I said, what is the type of 4, and what is the type of 4.0, I'll get the first one is an integer and the second one is a float. So by putting that decimal point in, you're telling it to store it as a float even though it is a whole number, and so it will behave like a float, while this one will behave like an integer. Okay, yep, Aaron's corrected himself. So moving on to data types, text. Text is stored as strings of Unicode characters. Oh, I've got another question here. What would be 1 divided by 3? Well, you know, you're sitting in front of Google Colab here. It's just the perfect place to find out what these things are. So what's 1 divided by 3? It's 0.3333. So, you know, the question, I'll just create another code cell. What's 1 divided by 3 times 3? And that comes out to 1.0. So that's quite good. But if you say, what is 1.1 plus 2.2, we get 3.3000, and that's an example of a floating point error, because these decimal numbers can't be converted exactly to a binary representation. When you do this sum, it then tries to it does it in binary, then converts back to decimal, and it doesn't get it quite right. So we see it puts a 3 on the end. Okay, Aaron, I think all division operations return a float. Well, that's yeah, that's pretty good. There is a division operation which we will see soon, which uses a double division. So if I say 9 divided by 3, and you see that returns a 3, that's an integer without a decimal point. But we'll talk more about that later. Okay, strings can be be enclosed in single quotes or double quotes, and you can swap between them. So the single quotes, if you choose when you want to do it, if you wanted to put double quotes into your string, then it's easier to enclose it with single quotes, and then the double quotes will just be treated as a double quote. And I'm just going to put my phone on silent, stop these calls keep coming through. And so a string, if you wanted single quotes in your string, then you can enclose the string in double quotes. Let's So I'll just go back to the questions because we're still talking about floats here. It won't be accurate, but has a limit to accuracy. Must go scientific notation. Yeah, so we'll talk about that later. All right. Now, sometimes you want to have single and double quotes in a string, so then you can use what's called a triple single quote or a triple double quote to start and finish your strings. And these ones with the triples, you can even put line feeds in there. So it starts the string on this line and finishes it on this line. So let's have a look at these 4 strings and see what they look like when they're printed. So you see the one here with the triple single quotes, we lined up the L straight under the A, but the way we did that was by putting all these spaces in front of it, and those spaces got remembered, so when we printed it out, they're still there. So if you want to have your second line of a triple quoted string starting at the beginning of the line, you have to remember to take it right to the beginning of the line like that. Everything else is pretty straightforward. Now there's some special characters you can put in strings, just like in other programming languages. New line is \n, carriage return is \r. A single quote, for example, if you were in a string that was delimited by single quotes, then you could use \single quote to make sure your single quote was considered as part of the string and not as a delimiter. And similarly, \double quote. That means how do you actually show a backslash if you want to, and the way to do that is with 2 backslashes. So let's print these strings out. I've used the print command here with commas in between, which so print with commas will by default just put a space between each thing. So I've got, it's printed out the number 1, then it's done a new line, then it's printed out the number 2, which we don't see there because it's then done a carriage return, which has taken it to the beginning of that line, and then it's printed a space, and then the number 3, and then a single quote, then the number 4, then the double quote, and the number 5, and a backslash. Now you can do some clever stuff with strings by starting them with a code outside the double quotes, and the 4 codes that exist are U, B, R, and F. So U says I want it to be a Unicode string, and that's actually the default in Python 3, but the prefix is required if you're wanting Python 2. And so you can put the prefix in Python 3 just so that you can write code that's compatible with both Python 2 and Python 3. My recommendation is don't worry about Python 2 anymore, it's gone. But if you do want to use Python 2 strings, then you can put the B in front, and that makes a byte string. You can do a raw string where the backslash is just a backslash, and so it won't escape any of these other characters. And you can also do an F string, and they're my favorite sorts of strings. They're called a format string, and you can include values in the expressions. So Google Colab has noted that this is an F string just by seeing the F out the front there, and so it's done some color coding for us. Whenever we've got these curly braces, the string will substitute in the value of what gets evaluated here. So that'll be the value of A, that'll be the value of B, and that'll be the value of A plus B. So let's print these out and see what it looks like. So in our format string, we've got 3 plus 4.5 equals 7.5. Now I'm going to be using these format strings quite a lot. So if you can get your head around this, how it works, then that'll make it a lot easier to understand from now on. If you're having trouble understanding it, let me know, because I'm just assuming people can understand it. But if you do, then I might have to go back to a simpler way of displaying stuff. All right, now we're getting on to operators, which we were discussing before, how to do division. So we'll start with integer operators. So these are all things you can do with integers, and let's see what they return. So we've got the plus sign, gives us addition, and that returns an integer. minus is subtraction, so integer returns an integer. Asterisk is multiplication, so integer returns an integer. And double / is called integer division or floor division. So 27//5 is 5, because that's that gives you 5 remainder 2. So it just takes the quotient from that, which is the 5. 27%, 5 is the modulo or remainder, and so that'll give you the 2. So if you want those two, the division and the remainder, then you use those operators. And finally, we've got the power operator, which is double asterisk. So 27 to the power 5 returns this number here. Now, if we do the same thing with one of those values being a floating point, even though it's a whole number, but it's got a decimal point in there, let's see what gets returned. So that returns a floating point. They all return floating point numbers, even if just one of them was. And this one here, the single division operator, that would return floating point, even if they were both integers. Okay, so I've got a challenge here for you. Challenge 3, store in variable C the number 123,456,789, and then display double that value. So if I go C equals, because that's the name of my variable, and I use the equal sign to assign the value to it, and then the number, and then I want to display double that value. So I say 2 times C. What is that? And it's this 246,913,578. Now, here's a solution provided for you, just to show you a few different ways that could have been done. So when we type the integer in, you can put these underscores in. They're not Python just ignores them, but sometimes it's useful to put them in yourself so that you can see where the thousands are. You can't use commas, because obviously commas means something else in Python, but they let you put in underscores. And so I've seen that, and it actually makes it quite a lot easier to read these large numbers if you put underscores in there. We can store double the value of C in a new variable D, and let's print out these solutions. So all right, let's just run this and see what it looks like. Solution 3 using an F string, double C equals, and there's the number, same number we got. That's good. F strings can also evaluate, so I put 2 times C in the curly braces and it evaluates that and then displays the answer. And you see here in my F string I actually wanted to display the curly braces, and so to do that I had to do double curly braces. So that gives me a single left curly brace, and that's a single right curly brace. I can even put formats in my F string, so anything after a colon in an F string is a format, and so I can say please use underscores for separating my separating the numbers to make them easier to read, or I can say use commas for display. In fact, this is the one that does the formatting. This one is just to display what I'm doing. And I can even say I want it to be 17 characters wide. I want to use commas for separating the thousands, and I want to use full stop, and after the full stop for the decimal point I want 3 decimal places, and the number I'm giving you is a floating point number. So there's a lot of information there and how to do formatting. I'm not going to try to teach it to you comprehensively. I'll just show you as we go along so that you can just pick this stuff up. So you can see here 3 decimal places, commas separating the thousands and millions, and it's 17 characters wide, the total length, and that's what that format string there, that's how it shows it. Similarly, this one here just says use commas for separating thousands and millions, and this one just says use underscores for separating thousands and millions. Okay, challenge 4, find the remainder after integer dividing an odd number by 2. Try an even number. Okay, so let's try an odd number. 7's an odd number, and I want to find the remainder after dividing by 2, and it is 1. Okay, let's try the same with an even number. 6, remainder after divided by 2 is 0. Okay, so that can be useful way of determining if something's odd or even. Any odd number is going to show 1, any even number is going to show 0 when you do modulo 2 on it. So solution here, and I'm showing you how to do a loop here, and this is a loop in Python. I say I want I to go in range 5, so it'll go from 0 up to but not including 5, and then do everything that's indented. So Python uses indents for saying what's in the loop, and this is different to just about every other programming language I know. Usually they'll put like curly braces around them to say what's part of the loop. This one, you just put a colon here to say I'm starting a loop or starting a new code block, and then anything that's indented will be in that code block, and then anything that's after that that's not indented is not in the loop. So I'll just say print not in the loop and see how many times that gets run. So let's run this loop. It's going to run 5 times, range 5, starting at 0, 1, 2, 3, 4, and then after it's finished the loop, then it prints the next line. It does the next line, which is print not in the loop. And we can see modulo 2 on each of those numbers goes 0, 1, 0, 1, 0, 1. So that's a great way of getting some sort of alternating pattern to happen. If you say, wanting to shade stripes at different colors going backwards and forwards, then you'd use modulo 2 on some sort of loop like that. Alright, advanced bitwise operators. So these all exist in Python. I'm not going to spend any time on them, but if you're coming from another language, you might go, how do I do bitwise operation? And what they do is they look at the binary values of these values and comparing each bit of the binary values. So 10 in decimal is equal to 1010 in binary, 3 is equal to 0011 in binary, and so if you do bitwise OR, which is what that is, it says use a 1, get a 1 if either of them are 1, so the answer to that will be 1011, and if you convert that back from binary to decimal, you get 11. Alright, so they're the bitwise operators, just there for your reference if you're experienced enough to know what they mean. Okay, so that we've done integers, floats, bitwise. Now we can do strings. What operators work on strings? Well, you can use the plus operator and the asterisk operator. So here I've got an asterisk 3. Well, asterisk 3 means multiply this string 3 times, so I get well, and then add it to 3 holes in the ground. So that gives me well, 3 holes in the ground. So you can add strings together just to make a longer string using the plus operator. In fact, you don't even need the plus. You can just put these strings. I've got a string here, 1, and then I've just put a space there, and then another string with apostrophes. I don't think it's very clear code, so I've never do it this way, but if you want to or you see it somewhere else, that's what's happening there. Those strings are getting concatenated together. Alright, so let's have a look at some of the interesting side effects of these different data types. Integers can have more significant digits than floats, so as the versions of Python have increased, they've decided just to let integers be as big as you want them to be. So if you do a long integer, it will keep it. It'll use up as much memory as required as to store that integer. Let's print these out. So you see 25/7, that converts it to a floating point number, and you only get that number of significant figures, which is about 17. But if you do that as an integer and just keep in your head where the decimal point should be, you can get many more decimal points and many more values after this virtual decimal point for this equation for 25 divided by 7 because you're doing a much larger number, and they all display. So like I've seen people use this technique when they're calculating pi to hundreds and hundreds of decimal places. They just store it as integers and do the maths on that, and it all works, and it's a fantastic way of how flexible Python is. Alright, as we saw before, floats can't store decimal numbers exactly, so that's great for science but not good for accounting. So if you're wanting to do an accounting, you would use integers with cents, or you can use dollars and use the decimal class, which we'll look at later. So yep, 1.1 plus 2.2 gives you this large number because of that problem. Find the integer quotient and remainder when dividing 66666 by 235. Okay, so the integer quotient, we use floor division, and that gives us the quotient, and we can also then do the remainder. So it's 2836, remainder 206. Calculate 2 to the power 10. So that should be something like 1024, I think. Yep, 1024. Find the decimal quotient of 666 divided by 235. So in that case, we'll just use the single division sign. And you can see that's yep, I've put the wrong number in there. 2836.87, and here we had 2836, remainder 206. Store in a variable the name of your favorite programming language as a string. Alright, so let's say S equals Python. Construct a new string that includes the value of the variable in the middle. Okay, so there's a couple of ways of doing that. I'm going to go yep, programming in plus S plus, now I need the plus sign here because it's got a variable name rather than just a bunch of strings, is fun. And there we go, programming in Python is fun. Okay, now solutions to all those exercises are here, and I think that should be a 5. Let's run that again. Yep, that looks good. How are we going so far? No more questions? Good. So let's have a look at Boolean data types. So true and false. So these are built-in keywords, if you remember. And if we look at the type of either of them, they're both bool. Now we can evaluate expressions to see if they're true or false, and to do that we use the double equals, and that's an equality tester. So single equals we use for assigning a value to a variable. Double equals we use for comparing if two things are the same. So 3 equals 5 minus 2, that's true. We can also, rather than equals, we can check for greater than. 45 greater than 23, that's also true. Minus 10 less than minus 20, that should be false, and it's false. C1 equals Python, that's true. So we can compare strings as well. Predict the outcome of the following Boolean expressions. Okay, so these are format strings. So you're really only interested in what's in between the curly braces here.
So we want to say, what is C1 equals to Python? So that one, I'll let you have a think of that, about that one. And once we've thought about it, we run it and see what comes up. And it says that returns false because C1 is Python with a capital P. So you can see that equals for a string is case sensitive. Now this one we're looking at, C1, and this expression does not equal. So they've used an exclamation mark and an equal sign, and that's supposed to sort of represent the does not equal sign, which is an equal sign with a line through it, which is not easy to type. So this is an easy way of typing that, and that should come up as true because of, once again, a case sensitive check. All right, 253 greater than or equal to 1518 divided by 6 gives true, and less than or equal also returns true. And so that's greater than or equal. This is less than or equal. So it could be greater than or it could be equal. And in this case, it's equal in both cases. So they're both true. Now we're going to look at the mathematical value for E, which is like 2.78, versus pi, which is 3.14, etc. 2.718 is less than pi, and so this expression here returns true. You can even do an expression with two comparisons in the expression, and it does both of them with basically an AND. So we want to make sure that E is less than 2 times pi and 2 times pi is less than tau. So let's see how that turns out. So E is that, 2 times pi is that, tau is exactly the same as 2 times pi. So this expression will return false because that section didn't work. Okay, now let's look at comparing strings. They compare on their Unicode value. So A is less than C, that'll return true because it compares on the Unicode value. But what about lowercase a compared to uppercase C? In this case, that's false. Uppercase C is actually less than lowercase a in Unicode. So any uppercase characters are going to be less than the lowercase equivalents. So that's just something to be aware of when you're sorting. And if the first character is the same, it looks at the second. If the second character is the same, it looks at the third. So in this case, it's going to compare the T to the R when it's looking at catch and carriage, and so that comes out as false. One of the other operators we can use for evaluating Boolean expressions is the in keyword. You can see it's the keyword's all nice and blue there. So AT in catch are the letters AT in catch, and well, let's just run it and see. They are, that's true. AC, are they in catch? They are in catch, but they're not adjacent to each other in catch. So that string is not in that string, so that's come out as false. And similarly, TA, it's in a different order, so that comes out in false as well. True or false, so or is a keyword as well as true and false being keywords, so it's in blue. So or just needs one of them to be true, and requires both of them to be true, so in that case true and false is false. And you can string them along, true or false, and false returns true because and has precedence over or. So if the order of operations, if you've got something like this, it'll evaluate the and first, false and false, so that is false, and then it'll go true or the result of that, which was false. So true or false will give us true, which is what it does. I can never remember that one, so I have to check it out. I would normally put parentheses in just to make sure that I get it right. And similarly, this is doing another and an or. False and false or true returns true. There was another keyword, which was the is keyword. You'd normally only ever do that if you're checking for none. There is only one none in your Python system, so if anything is none, then it is the same memory location as anything else that is none. And that just saves on memory. So if I say C2 equals C1, then C1 is C2, because they refer to the same part of memory. And that's useful when you're looking at mutable data types. If you change one of them, then the other one will also change. But that's a bit more complicated, so we won't talk about that tonight. How are we going? So list, another data type, really flexible in Python is the list. So it's like in JavaScript you have an array, and you can have different data types within the list. You can even have lists within the list. So here we've got strings and integers and floating points all in the same list, and they print out. You can print it out very easily, and it prints out. So it's got the square brackets, tells it that it's a list. There's zero index, so I can look at any item in the list. The first item will have the index 0, so that should be 6. Yep. And the second item will have index 1. And list 6 is 0, so that's up here. But a really useful feature is you can index backwards. So list -1 will give me 0. So it's counted back from the end. And so I go -2, -3. So if I want the last one, I don't have to calculate the length and then subtract 1. I just go -1, and it does. Python does it for me. -2 is 1. If you want to find the length of a list, use the len function. That tells me there's 7 items in the list. You can also slice up a list, 2 to 5. Okay, I've got a question here. How does it handle JSON? So that's a pretty good question. I don't think I'm going to be looking at. No. So you could say like list is a very similar format to the array format in JSON. And there's also another data type called a dict, which is very similar to the object format in JSON. So if I said D equals, and I use curly braces just like in JSON, and now I want to put in my key and value, but I have to use it as a string as my key. Well, it doesn't have to be a string, but if I wanted to use a string, I have to put quotes around it. While if I was in JSON, I don't have to put the quotes around that. And then I can put my value here, and then another key. And the advantage of doing that is that I can actually use variable names in the keys, which is quite a flexible thing. So if I now want to print that out, it shows key, value, another key, another value. But I could use let's do I could use list 0 as another key, and I'll just call that V3. And so it's looked up list 0, it found it's got the string 6 in it, and so it's used that as the third key in this dictionary. So it's a bit more powerful than your standard JSON, but it's a little bit more typing because you've got to type quotes around all your keys. Okay, slicing. So we can go from 2 to 5, and the number of returned elements will be the second number minus the first, so 5 minus 2, we've got 3 elements returned. And the way I like to think of the indexes is their positions between the actual elements. So if these are the elements of my list, then these are the indexes. So 2 is here, so 2 is that one there, and 5 is there. So my slice is going from 2 to 5, and so it gives me 4, 3, 2, and that's the values that are there. So other people say, oh, it starts at this one and goes up to, but doesn't include index 5. That works as well. You can also use negative indexes, so that would be the same as list of -5 colon -2, which by coincidence happens to be the same, just negatives, but that's because we started exactly in the middle. When you're slicing from the beginning, you can omit the first 0, so up to but not including 4 gives us 4 elements. You can also slice from any position and go all the way to the end by not putting anything at the end. And there we go, 3 to whatever. And when you think about it, we don't actually have an index for up to but not including the end. So, well, I guess we could have put a 7 there. That would work, yeah. So 3 colon 7. But we can't put we haven't got a negative one, so we would have to know the length to put in the 7. But by doing that, we don't need to know the length. It just says go up to the end. You can even use 2 colons, so I forgot about this one. And you can step up in 2s, so 5, 3, 1. We can slice backwards from the end. So because it's a negative step, it's stepping backwards. This -1 here says start from the last element, and this says go forwards up to but not including the first one. So 4, 0, 1, 2, 3, 4. So it didn't include the 5, which is at index 1. Let's have a look. There's our list. We can assign a value to any part in the list. So list second value, we want it to be 4, and now it's got FOUR instead of 4.0. We can change that string to blast off, 654321 blast off. We can delete any element within it using the keyword del. So you can see 3 is now been taken out. Alright, so they're all things you can do with lists. Strings are similar to lists as they're an iterable string of characters. So we can do a few of the same things, like we can slice it and get 3 to 7 out of this, which is D, E, F, G. Alright, now I'm going to show you the decimal class. That is how you handle floating point numbers without any binary encoding. Now, as soon as we type in a floating point number 1.1, it's going to go straight to binary, and then if we had to convert it to decimal, it wouldn't work. So we have to put them in as strings, because that's saying I want those characters, I do not want it converted to binary first. So decimal can take that string and work with it, and it will store it as a member of its own class. So import the decimal class, and we're using the capital D decimal class within it. Sorry, this is the module. That's the module. This is the class. And so 1.1 plus 2.2 is returned as 3.3. Now that's a pretty verbose way of doing it. You can just say from the decimal module, I only want one class, which is this decimal class. And so anything I refer to now as decimal with a capital D, I want it to be the one that's come out of decimal. So that's a different way of doing the import command. And then I can write things a little bit more succinctly. So now it's I just write decimal 1.1 plus decimal 2.2 rather than this long-winded thing here, and it gives me 3.3. Now if you're using decimals quite a lot in your program, I've seen people do this: from decimal import decimal as D, and that's an alias. So they've renamed. We're saying import it, but also rename it, so I don't have to type decimal every time. And you just do D 1.1 plus 2.2. It'll display the full decimal class name, but we can use it with this shortened name whenever we're using it. Those aliases, you can use them on the entire library. So this is pretty common. Pandas is normally imported just as PD rather than the full pandas, NumPy as NP. Okay, so that's the end of the session. Are there any more questions? The keywords we've covered so far are all of these. So let's count that. 14. So we covered 14 of the 35 or so keywords. So you've know almost half of all the keywords we've just taught you in 1 hour. There's probably a bit more to some of them than what we've done, and the ones that are left are probably a bit more complicated. But I hope you had fun. Next week, Arun will probably be doing an online session, and then the session after that will be online. I'll be giving that. That'll be all about creating PDFs. Gupta says, I'm the best presenter and teacher. Well, thank you. That's very nice. I sometimes feel like I'm going a bit fast, but if no one says anything, then I'll imagine you're keeping up. And you can always replay the video back later if it is too fast. So our next in-person session will be on the 3rd of May, and I will set up a meetup for that. And it will be at Brisbane Business Hub, and the registrations will be handled by Brisbane Business Hub this time. So we're doing this one as a joint session with Beginners Python and Machine Learning and Brisbane Business Hub, and it'll be about machine learning, and it'll be at the 155 Queen Street in the Brisbane Mall, in the Queen Street Mall. Okay, thanks Aaron, thanks Gupta, and everyone else who's been watching. Thanks for all the questions. It really helps that you've been asking questions and saying stuff, so that I can just see what you're keeping up with and what you're not, and noticing where the holes are and what I'm doing. So I'll see you in a fortnight's time. Bye.